Alright, so what if we mix these transformations together? We've looked at a few examples, doing maybe 2 of them at the same time, but we want to get to a place where if we have numbers for A, B, H, and K, we have numbers in all of those spots, positive, negative. We want to have an approach for evaluating that transformation. So, there is an order to follow. It can differ a little bit, but basically you want to take care of stretches and compressions first. So first thing we're going to do is stretches and compressions. And it really doesn't matter which one you do first. But I'm just going to have, it's easier to go through these with a clear set of rules. So I'm always going to start with vertical. If you start with horizontal, it'll be okay, but I'm going to start with the vertical stretch and compression. And then if that value is negative, then you'll also take care of that reflection across the x-axis. So we'll do those at the same time, these stretches, compressions, as well as reflection. And then we'll look at B, which will be the horizontal stretch or compression. And then if B is negative, then we'll have that reflection across the y-axis. And then after we do those 2 pieces, then we'll move on to shifting. So we'll move horizontally, and then we'll move vertically. It doesn't really matter which one you do first there either. Really the important piece is stretch, compression first, and reflections, and then saving the shifting left, right, up, down to the end. Alright, so let's practice this. So here we have our original function, and we're going to go ahead and move it around. Okay, so what I did is I went through these graphs and just kind of set up the scale, and you can always readjust the scales. I just kind of change them based on how well it fits once I start making these transformations. I also like to draw the original function on there, just so you can kind of move the pieces. Okay, but before we start graphing anything, what we need to do is just look at our function. Now, something about that letter B, that horizontal stretch compression, something that's important to notice is in the original form, that value of B is factored out of the expression. So there might be something multiplying with x, but if that plus or minus h is not in parentheses, then what you need to do is look for a greatest common factor between those 2 values. So that's what's happening in this first case here, is I can see something multiplying with x, however, I have something adding and subtracting on, and it's not factored out. So what I'm going to do is rewrite my function notation. So I have y equals w is my function name, of, and I'm going to factor out 2, and that'll leave me with an x minus 3. And then I have this minus 2 on the outside. Alright, so reading across my function, I don't have anything multiplying outside of the functions. It's like I don't have a value for a, so I'm not going to have any vertical stretch or compression. I do have a horizontal stretch compression, and since that value is 2, so it's large, it's going to be a compression by a half. And then we'll shift, and you can do those at the same time or separately, but basically with that negative 3 inside, so horizontally that'll move me to the right 3 units. And then with the minus 2 outside, that'll be down 2 units. Okay, so I'm going to take care of the compression first, and then we can do the shift. So, horizontal compression, what that's going to do is take these distances away from the y-axis and cut them in half. So where I have this distance of 5, it'll now be 2.5. So this value moved here. And then where I have this distance of 4, that'll be 2. Distance of 3, 1.5. Distance of 2, 1. Distance of 1. So that open circle will be at a half there. So that horizontal compression by a half will give us that shape there. Then I need to move right 3, and we could do this all in one step. In fact, let's go ahead and do that. So I'm going to move to the right 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. With an open circle there. Sorry, I grabbed a big pen here just to make it clear where we're ending up. Oh, that was a shift right 3, but I didn't do down 2. All right, one more time. Almost there. I will graph that. I said I was going to do in one big step, but that's fine. Okay. Got too excited choosing the big pen. Okay, now we'll go down 2. So 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. Okay. Just going to make that clear that that's an open circle there. Alright, there's where our function ends up. So, compress by a half first, then move right 3 down 2, and that's where our function ends up. Alright, this next one. We have this negative on the outside. You can see inside, again we need to factor first. So this is going to be the same thing as y equals negative w, and then we're going to factor out a negative 1, which will leave us with x plus 3 inside our function there. So this means is first we're going to take care of a, which is just negative 1. So that tells me to reflect across the x-axis. Then for b, we also have a negative 1. So that's going to reflect across the y-axis. And then we have this plus 3 right here. So with the plus 3, that's our horizontal shift, and that'll be to the left 3 units. Alright, so reflecting across the x-axis. So we're taking our y values and changing their sign. So what that will look like is moving down here below the x-axis. We just take those y coordinates, and they're now all negative where they were positive before. Then we're going to reflect across the y-axis. So like my open circle piece here, it's going to reflect over. So where it's an x value of negative 1, now it's going to be at positive 1. And then where I had an x value of negative 2, now it's at positive 2. Negative 3 is positive 3, negative 4 is positive 4, and so on and so forth. So there are the reflections. And then our last piece is to move to the left 3 units. What I'm going to do is go 1, 2, 3, and I'll give you the open circle, and 1, 2, 3, 1, 2, 3, 1, 2, 3. Can notice that the scale, I made the y-axis, the x-axis going a distance of 2 there. It's because we're going to have this big stretch horizontally. I know 3 isn't big, but it can cause a big stretch that will make it hard to see. So when setting the scale, I kind of look at what we're dealing with. The vertical stretch is pretty big too, but 2 isn't too bad, but that vertical stretch of 3 might take us off the x-axis. So what I'm going to do is rewrite my function there so I can clearly see b. So all that's going to entail is taking that 1/3 in front of x so I can clearly see my value. Then we don't have anything adding or subtracting on. And I have plus 4. Alright, reading across the function. A equals 2, so that's going to be our vertical stretch. So it's vertical because it's outside the function. And then because 2 is larger than 1, that'll make it a stretch. And then we're stretching by 2. And we just use the value that's there. Then our next piece, looking inside the function, we see that 1/3. So that's going to be a horizontal change because it's inside the function. And then the multiplying with x is going to be our stretch or compression. And because it's between 0 and 1, that's going to be a stretch by, and then again, you could think of the reciprocal, like flipping the numerator denominator. So it's going to be the stretch of 3. And then our last piece is this value adding outside of the function, which means it's vertical. So that's up or down, and because it's positive, that'll be up those 4 units. Alright, so first thing we're going to do is that vertical stretch by 2. So what I'm focusing on here is looking at where my y values are, and I want to double those distances. So, reading left to right, that first one has this distance of 3, so that'll make it a distance of 6. Distance of 1 becomes a distance of 2. Distance of 2, distance of 4, 2, 6. Alright, so here's that step of the transformation where we just stretch all those vertical distances by 2. Next, we're going to stretch the horizontal distances by 3. So now what I'm looking at are these distance away from the y-axis, and I want to triple those distances. So where I have this distance of 5 right here, I want to make it a distance of 15. 2, 4, 6, 8, 10, 12, 14, 15. Down here, I have this distance of 4, so multiplying by that 3, I want 12. 2, 4, 6, 8, 10, 12. And let's see, this distance of 3, so multiply by 3 will be 9. 2, 4, 6, 8, 9. Distance of 2 times 3 will make that 6. And then a distance of 1 times 3 will make that a half. So here we have our vertical stretch and horizontal stretch all in one. So then our last step is to move these points up 4. So up 4, up 4, 1, 2, 3, 4, 1, 2, 3, 4. And with that, we'll have our function. There we go. All right, so our last example here, or sorry, actually I do want to point out when you get to the end here and you're like, well, I hope I did that right. If you've labeled these steps correctly, which I highly recommend writing out these steps and putting them in order before you start graphing, what you can do is a quick check. So like vertical stretch by 2, what I can notice is my original function, like vertically spanned this distance of 2 squares. So if I stretched by 2, I should now span 4 squares. So we did in fact double that vertical distance. For the horizontal stretch, what I could see is, let's see, we went from -5 to 1, so we kind of spanned 4 there. Yeah, this distance of 4. And if we tripled that, we should now span this distance of 12. So I go 1, 3, 5, 7, 9, 11, 12. So I can make sure that I am spanning 3 times that distance now. And then with the +4, kind of, that's a little trickier because it shouldn't just be 4 up from the original, because those stretches and compressions will make a difference. But usually it's the stretches and compressions where the errors come through in terms of getting the correct shape of your graph. Alright, our last piece here is to work in reverse of what if we're given the function and how can we find the transformation. So I'm just going to draw my original function here. So, in thinking of how this had to change to get down there, one thing I could quickly notice is we're going to need to reflect over the x-axis. So I'm going to go ahead and write that down. Reflect over x. Which, to do that, to flip over the x-axis, is where we'd multiply by -1 on the outside of the function. So taking those y values and just changing their sign. Then what I want to do is I just want to focus on the compressions and stretches first. So, and it doesn't matter which one you think of first. So where I can see, let's look at vertically. Vertically, we span this distance of 2, but where my function ends up, it spans this distance of 4. So I'm going to need a vertical stretch of 2. So what that would look like is 2 times f of x for a vertical stretch of 2. So that's going to be part of it. Horizontally we span this distance of 4, and where we end up is just a distance of 2. It's like from 1/2 to 2.5. So with that, we are compressing horizontally. I'm going to make a note of that. Compress horizontally by 2, or like 1/2. We're shrinking it by 1/2. So what that would look like is multiplying inside the function, we'd have 2 times x, because we use the reciprocal of it. So that would make it a compression by 1/2. And with that, before we think about shifting anything, let's just do those transformations. So I'm going to reflect over the x-axis, which means if I'm +3 there, I'd have -3. So a reflection would look like this. If I do my vertical stretch of 2, so that's going to bring me actually out here to 6, and then 1, 2, 2 will turn into 4, 1 will turn into 2, and then where I have 3, that'll also be 6. So I'm a little off the page there, but it's okay. It's not too far off, just by 1. Okay, then horizontal shrink. Oh, I'm running out of colors. I'm going to go back to red. In fact, I'm going to get rid of the red there. So that took care of the reflection. So now I'm here at the green function. And now I'm going to do my horizontal compression. So where I have these distances, I'm going to cut them in half. So where I am 5 away, I would now be at 2.5. Whereas 4 away, now it'd be 2. 3 away would be 1.5. And 2 away would be 1. And 1 away would be 1/2. Okay. So with the compressions and stretches, I now have the correct shape. All I need to do is move it. And what I can see is the movement that I need is, like if I follow this coordinate, I just need to move that up 2 spots. So that's going to be my last piece, is to go up 2. So that's a vertical change where I'm adding 2 on the outside. And that will get me there. And all of those pieces will work. Like that will go up 2, so on and so forth. So I want to create a function that puts all of these pieces together. Negative outside, but also 2 outside. So really I have this -2. Sorry, what's my function name? Is w. And then inside, I'm going to multiply x by 2 to get that horizontal compression, and then we're going to add 2 outside. And that would be our function. So that's how we could work in reverse. Just think about stretches and compressions first, then see where you end up after doing those pieces, and then if you've done them correctly, you should have the general shape. It's just a matter of moving left, right, up, down, and you can add those into the function pretty easily.